Hello and welcome back again to Chemistry. It is all that matters, and we are going to continue with the gas laws by looking first at the combined gas law. Now the combined gas law is called the combined gas law because it basically takes the first three laws we looked at, Boyle's, Charles, and Gay-Lussac, and combine them into one single equation. And that equation is P1 V1 over T1 equals P2 V2 over T2, or initial pressure times initial volume divided by the initial temperature equals the final pressure times the final volume divided by the final temperature. Now some people like this to be a linear equation, so they set this up as P1 V1 T2 equals P2 V2 T1. What's most important to remember is that using algebraic properties, you can isolate any of these variables at any time by conducting the math. Now, technically, we only need to use the combined gas law. We don't need to use Boyle's, Charles, and Gay-Lussac's law. Typically, those laws take place because one of the variables is held constant. So if we hold the temperature constant, we get Boyle's law, P1 V1 equals P2 V2. If we hold the volume constant, we get P1 over T1 equals P2 over T2, which is Gay-Lussac's law. And if we hold pressure constant, we get V1 over T1 equals V2 over T2, Charles' law. So technically, you only have to remember this law, the combined gas law, because in using the combined gas law, you can solve all the other three laws that we've introduced so far. So let's solve a problem using the combined gas law. So here we have a gas held in a flexible container at 20 degrees Celsius, 900 torr. The container is 2300 milliliters. If the container expands to 3.1 liters, when the temp increases to 30 degrees Celsius, what will the pressure of the gas be? So our initial pressure is 900 torr. Our initial volume is 2300 milliliters, but we're going to convert that to 2.3 liters because we see that the final volume is 3.1 liters and we want to keep our units constant. Next, we look at the temperature, and our initial temperature is 20 degrees Celsius, and for the gas laws, we must always convert to Kelvin, so this is 293 Kelvin. We are looking for the new pressure, and since we're working in torr originally, we're going to keep that in torr. And then lastly, we are going to have a 30 degrees Celsius change in temperature, and that gives us a 303 Kelvin value. So first, we identify what you know and what you don't know. We need to make sure that our units are consistent, and we need to make sure we're always working in Kelvin for the gas laws. So once we've identified everything and we make sure that the units are consistent and we make sure that the temperature is in Kelvin, we can plug our values into the equation. P1 is 900 torr, V1 is 2.3 liters, 293 Kelvin is the original temperature. We are looking for the final pressure. The final volume is 3.1 liters, and the final temperature is 303 Kelvin. Doing a little algebraic math, we can rearrange the values so that 303 Kelvin times 900 torr times 2.3 liters divided by 3.1 liters and 293 Kelvin will give us an answer of our final pressure. Now liters will cancel with liters and Kelvin will cancel with Kelvin, and our value will come out in torr, and our final pressure is going to be 690.53 torr. We need two significant digits because of the 2.3 liters. Remember that temperature is never the significant digit or never used as a significant digit. So technically our answer is 690 torr. So let's look at a second example. Here we have gas held in a balloon, and the balloon is being heated from 20 degrees Celsius to 193 degrees Celsius. The pressure changes from 700 to 1950 torr, and if the container expands to 330 liters, what was the original volume of the balloon? So once again we list our values. 700 torr. We're looking for the original volume. 20 degrees Celsius changes to 293 Kelvin. 1950 torr. 330 liters is our new volume, and our final temperature is 190 degrees Celsius, which comes out to 463 Kelvin. So we have identified our knowns and unknowns. We have balanced our units to be consistent, and we have changed every temperature to Kelvin, which is necessary for all of the gas laws. Once again, we plug our values into the equation. 700 torr is our initial pressure. We are looking for the initial volume. 293 is our initial temperature. 1950 torr is our final pressure. 330 is our final volume, and 463 Kelvin is our final temperature. So our final volume algebraically comes out to 950 torr times 330 liters times 293 Kelvin divided by 700 torr times 463 Kelvin. Our torr will cancel, our kelvins will cancel, and we will get an answer in liters. And for this case, this value comes out to be 582 liters. So, using the basics of the gas laws, pressure, volume, and temperature, making sure that your units are consistent and that you always work in Kelvin, you can rearrange any of the units in the combined gas law and identify the unknowns. Keep working on your chemistry.